Hello students. Let's consider few questions as ChainRule practice test, which are very important from the competitive examination point of view. If you want to practice these questions, please visit our website www.examsnet.com. You can also download our app. The link is given in the description box. So let's begin with question number 1. If the wages of 24 men working for 9 days is 25,920 rupees, then the wages of 13 men working for 13 days is. So here, let us consider the wage of one man for 1 day, right? So one man in 1 day, how much he earns, right? That we need to consider first. Therefore, so here it is given that 24 men working for 9 days and they earn 25,920 rupees, right? So here one man, the wage of one man per day, right? We'll consider wage of one man in 1 day or per day will be, here students, 24 men, they work for 9 days. So number of persons in 9 days, they earn 25,920 rupees. Therefore, one person in 1 day will earn 25,920 rupees divided by 24 persons into 9 days. This much amount a person earns in 1 day, right? So simplify it. So 9 plus 2 here, the numerator number is divisible by 3, I think. So 9 plus 2, 11 plus 5, 16 plus 2, 18. So when you add these numbers, you will get 18, right? So sum of these digits will be divisible by 3. Therefore, the whole number in the numerator will be divisible by 3, right? So here in the denominator, both 24 and 9 are divisible by 3. So you can directly take 9. So 3 into 3 is 9. 3 into 8. 3 into 6. 3 into 4. Right? So again 6 plus 4 plus 8. 18 is divisible by 3. So 3 into 2 is 6. 3 into 8. 3 into 8. Yes. Therefore we get 2,880 by 24. Still we can simplify. So 8 into 3, can we check? 8 into 3, 8 into 4 is the remainder, then 8 into 6, yes. So we have 360 by 3, which is nothing but 120. So wage of one man per day is 120 rupees, right? One person earns 120 rupees in 1 day. Therefore, the question is how much, what is the amount that 13 men earn for 13 days, right? Therefore, the required answer is wages of 13 men, right, for 13 days is nothing but, so wage of one man in 1 day is 120 rupees. Therefore, wage of one man in 13 days will be 120 into 13 days, right? So this gives wage of one man in 13 days, right? So we are calculating for 13 men. Therefore, into 13 men. So we have to multiply by 13. So 120 into 13 into 13. So you will get 120 into 13 is 169. So we can directly multiply these two numbers. So directly take 120 into 169, 12 into 9, 108, then 12 into 6, 72 plus 10, 82, then 12 into 1 plus 8, 20. 20,280 rupees is the wages of 13 men for 13 days. 20,280. So look at the options. Option B is the right answer. Students, here in this question, first we need to find wage of one man per day, right? So it is given that, so 24 men, they work for 9 days and they earn 25,920 rupees. So total earning divided by total persons into number of days they work, right? So total persons into number of days gives wage of 1 man per day, right? Therefore, wage of or wages of 13 men for 13 days will be 20,280 rupees. Option B is the right answer. Question number 2. A bulb can light up 18 square feet room for 560 hours. Approximately how many bulbs of the similar quality are required to light up 54 square feet room for 176 hours? So here students, to light up 18 square feet room. So we'll consider a room whose area is 18 square feet square, right? One bulb is required, right, to light up this room for 560 hours, right? So we need to find how many bulbs are required to light up 54 square feet. So compared to the previous area, here 54 square feet is more, right? So the area of the second room is more square feet, right, area. For 176 hours, here the time duration is less, right? So for this, first we need to consider the number of bulbs required to light up 1 square feet area for 1 hour. I'll repeat once again. Bulbs required to light up 1 square feet area, right? So we'll consider the small area, so which is 1 square feet area for 1 hour. How many bulbs are required? First we need to find, right? Therefore, to light up this much area, which is 54 square feet area for 176 hours. Very easy questions. So we'll consider the given data. Number of bulbs required to light up. Bulbs required to light up 18 square feet room for 560 hours is equal to, which is already given, 1 bulb can light up, right? So which is equal to 1. 1 bulb is required to light up 18 square feet area for 560 hours. Therefore, number of bulbs required to light up 1 square feet room. 1 square feet room for 1 hour. For 1 hour. Right? Only to light up 1 square feet area only for 1 hour. How many bulbs are required? So which is nothing but 1 divided by 18 into 560. Right? So 1 divided by 18 into 560 number of bulbs are required. Right? Therefore, to light up 54 square feet area. Right? So 54 square feet area for how many hours? 176 hours. Number of bulbs required. Bulbs required is equal to, very easy question, to light up 1 square feet area for 1 hour, 1 by 18 into 560 bulbs are required, right? Therefore, that means into, right, to light up how much area? 54 square feet area for 176 hours. Right? So how many bulbs are required? Very easy calculation. So here 18 into 3 is 54. So we have 3 into 176 by 560. Right? So we'll start with 2. Right? Both the numbers are even numbers. So 2 into 8, 2 into 8. So here 2 into 2, 2 into 8. So directly you can start with, yeah, 4. Yes, can go for 4. 4 into 22, 4 into 70. So we have 22 by 70. So can 2 into 11, 2 into 35. So we have 11 into 3, which is 33 by 35, right, is the answer. So 33 by 35 number of bulbs are required to light up 54 square feet area, right? So again, we can simplify 33 by 35 is nothing but 0.9 something, right? So 0.9 something, which is approximately equal to 1, right? So in the options, whole numbers are given. So approximately one bulb is required, right? So 0.9, you cannot consider 0.9 number of bulbs here. One bulb is required to light up 54 square feet room for 176 hours. Option A is the right answer. Question number 3. In a fort, there is a provisions for 40 days for 275 persons. If after 16 days, 125 persons leave the fort, for how many more days the provisions will last? So students, so total provisions for 40 days, first we need to find for 275 persons. So the simple concept we are using here is work is equal to efficiency into time, right? If you consider work as provisions to be provided, right? So work as provisions provided, total provisions provided as the total work. So according to the concept, it is efficiency or capacity. Both you can consider efficiency into time, right? Here efficiency is nothing but number of persons into number of days, right? Here in a fort, there is a provision for 40 days. Here the total work is for 40 days into 275 persons. Provisions for 275 persons, not for one day. It is for 40 days. Therefore, it becomes 40 into 275, right? So we'll write total provisions. Total provisions is equal to, so 275 persons into 40 days, right? So if after 16 days, 125 persons leave the fort, that means for first 16 days, so all the 275 persons will be there in the fort, right? So for first 16 days, for 275 persons, provisions will be provided, right? So we'll write provisions provided in 16 days, right? So what amount of provisions was provided for 16 days? So it is 275. Number of persons in 16 days is equal to 275 into number of days, right? So you will get some value. 275 into 16 you will get 275 into 16. So you'll get 4,400. So 4,400 units is provision provided in 16 days, right? So what is the remaining provisions? Remaining provisions. So these remaining provisions for remaining persons. So remaining persons are 275 minus how many? 125 persons leave the fort after 16 days. Therefore, it is 125. 275 minus 125, it is 150. So remaining provisions were provided for 150 persons, right? So we'll consider remaining provisions. So remaining, what is the value of remaining provisions? Total provision was 275 into 40. And provisions already provided in 16 days is 4,400, right? So 275 into 40, you will get 11,000 minus 4,400, right? 4,400. So 6,600, right? 6,600 units is the remaining provision, right? 6,600 units. And the remaining persons are 150, right? So again, we are using the same concept to find number of days, right? For how many more days the provisions will last, right? So time is equal to, so since work is efficiency into time or total provisions provided is number of persons into days, here in place of total provisions, we are considering remaining provisions, right? So it is number of days. So how many more days the provisions will last? So which is equal to remaining provisions by number of persons, right? Therefore, remaining provisions by number of persons, right? So remaining provisions are 6,600 units, and number of persons after 16 days is equal to 150, right? So 6,600 by 150. So you will get, after simplification, you will get 44, right? Since it is time, so for 44 days, the remaining provisions will last, right? For 44 days. Option B is the right answer. Question number 4. In a canteen, 230 kgs of rice is required for a week. How much rice required for 49 days? So for a week, 230 kgs of rice is required. For a week means for 7 days, 230 kgs of rice is required. Therefore, how much rice required for 49 days? So required rice is equal to, so for 1 week, that means for 7 days, 238 kgs of rice required. Therefore, for 1 day, it is 238 by 7, right? So 1 day required rice is 238 by 7. Therefore, for 49 days, into 49, right? So rice required for 1 day into 49 days gives the required answer. Therefore, here 7 into 7 is 49. So we have 238 into 7. So simple calculation, 8 into 7, 56. Then 7 into 3, 21 plus 5, 26. 7 into 2, 14 plus 2, 16. So 1666 kgs of rice, right, required for 49 days, right? Option B is the right answer. Question number 5. If 9 examiners can examine a certain number of answer books in 12 days, working 5 hours a day, for how many hours a day would 4 examiners have to work in order to examine twice the number of answer books in 30 days? Here, students, to examine certain number of answer books, let us consider the number of answer books corrected be X, right? To examine X number of answer books, 9 examiners take 12 days of time. They work for 5 hours a day, right? So we'll consider X is number of answer books they examined, they corrected, right? So here, for how many hours a day would 4 examiners have to work in order to examine twice the number of answer books in 30 days? That means in order to examine 2x number of answer books in 30 days, right? So 4 examiners take, so how many hours of time per day, right? They work for 30 days and number of hours worked by them is how much? What is this? So this time be y hours. So we'll consider this time as y hours a day. They work for 30 days and in each day they work for y number of hours, right? So how many examiners? 4 examiners, right? So in order to solve this, to find the value of y here, so we'll consider number of answer sheets examined by one examiner in 1 day in 1 hour, right? So one examiner in 1 day and in 1 hour, how many answer sheets he examines, right? By taking X as the total number of answer books they examined, right? So we'll consider the given data. So number of answer books examined by 9 examiners, right? 9 examiners in 12 days, right? 12 days and working for 5 hours a day. 5 hours a day is equal to X. right? Let X be the total number of answer books, right? Therefore, number of answer books examined by one examiner in one day and in 1 hour per day. In 1 hour per day will be x by 9 into 12 into 5. Right? So that means 9 examiners in 12 days, and in each day 5 hours if they work. So they can correct or they can examine X number of answer sheets. Therefore, for one day they can examine, one examiner can examine in one day and in 1 hour per day. So the number of answer sheet will be X by 9 into 12 into 5. Here the question is in 30 days, right? So number of answer sheets examined by 4 examiners in 30 days is equal to twice the number of answer books, which is 2x. We need to find, so in how many hours a day they work, right? Therefore, let y be the number of hours per day in second case. Therefore, in second case, number of answer books is equal to, in second case, number of answer books examined by how many examiners? 4 examiners, right? Number of answer books examined by 4 examiners in 30 days, they are asking. In 30 days. So according to the concept, in one day, one examiner can examine X by 9 into 12 into 5 number of answer sheets, right? So therefore, in 30 days, so it will be this number into 30 days of time into how many examiners are examining? 4 examiners. In the second case, 4 examiners, right? Into how many hours per day? Y hours per day. Therefore, into number of hours per day, right? So here number of answer books in the second case is twice the original number of answer book. 2x is equal to, so x into 30 into 4 into y divided by 9 into 12 into 5. Simplified. Can cancel x and x. So here 4 into 3, 3 into 10 and 5 into 2. Then here also you can cancel 2 and 2. So y by 9 is 1, right? So 1 is equal to y by 9. So which is nothing but y is equal to 9. So what is y? Number of hours per day. So it is 9 hours per day in the second case. Therefore, 4 examiners, they examine 2x number of answer sheets in 30 days and 9 hours per day they examine, right? Therefore, option B is the right answer. Question number 6. A Flagstaff 17.5 meter high casts a shadow of length 40.25 meter. The height of the building which casts a shadow of length 28.75 meter under similar condition will be. So we'll consider a Flagstaff of length or of height 17.5 meter. It casts a shadow of length. Its shadow is 40.25 meter height, right? So if AB is the Flagstaff and its shadow is 40.25 height, right? 25 meters height. So the height of the building which casts a shadow of length 28.75 meter under the similar condition is. So we'll consider a building. So let CD be a building, right, which casts the shadow of height 28.75 meter. So this is the shadow of the building CD, Mn be the shadow of the building CD, and its height is 28.75 meter. This is shadow of building CD, and the previous one is shadow of the Flagstaff AB, right? So here we need to find height of the building. What is height of the building? So here an easy trick we can use. So here height of the building is equal to height of the building is equal to, so here when 28, sorry, the first shadow was 40.25 meter, right? When 40.25 meter was the shadow, right? So height of the Flagstaff was 17.5 meter, right? Therefore, if 28.75 meter is the shadow, what is height of the building? So it is given that under the same condition, similar condition. Therefore, no need to consider any, no need to alter any value here because the condition is same, right? For example, if 1 meter building produces 2 meter shadow, for example, right? So what does 3 meter building produce a shadow? At what height, right? So that means under the same condition we are calculating here, right? Here the weather conditions or any other conditions do not affect the shadow here. Therefore, it is given in the question as under the same condition. Therefore, so height of the building will be, so if the shadow height was 40.25, height of the Flagstaff was 17.25 meter. Therefore, if the shadow was 28.75 meter, what is height of the building, right? So simplification is very easy. Let us convert all these decimals into whole numbers. For that, let us express these meters in terms of centimeter. So 17.5 meter is nothing but, so 17.5 meter is nothing but 1750 centimeter divided by 4025 centimeter. So we are just multiplying each number by 100, right? Into 28.75 meter is nothing but 2875 centimeter, right? Therefore, we are expressing height of the building in terms of centimeters here. So very easy calculation. So all the numbers are divisible by 25 because the last two digits are, so here 50 is the last two digits here in the first number. Here it is 25, here it is 75. So all the last two digits are divisible by 25 here. So we can directly go for the division by 25. Say 25 into 1 is 25. 15 is 25 into 6. So 25 into 161 is 4025. Whereas in the numerator 25 into 1. So 3 is the remainder. 25 into 1 is 25. 25 into 5. So we have 1750 into 115 by 161. Right? So here 1750 into 115, you will get 2,01,250 divided by 161. So you will get 1,250. So in terms of centimeter. So here height of the building is 1,250 centimeter. In terms of meter, it is 12.50 meter is height of the building. Right? So very easy calculation. So option C is the right answer, right? 12.5 meter is the height of the building. Question number 7. The shadow of a tower which is 80 meters high is 16 meters at a particular time on a day. Find the height of a tree which casts a shadow of 9 meters under the similar condition on the same time and day. So on the same time of a day, so the shadow of a tower is 80 meters. So the height of the tower is given. Shadow of a tower which is 80 meters means height of the tower. So if it is the tower's height is 80 meters and its shadow is 16 meters, right? So shadow of the tower is 16 meters, right, at a particular time on a day, right? So we need to find height of the tree. So we'll consider a tree, right, which casts a shadow of 9 meters. Shadow of the tree is 9 meters height under the similar condition on the same time and day, right? So no need to alter any values here also, as in the previous question. Here also very simple calculation. So if the shadow was 16 meters height, right, if the shadow was 16 meters height, so height of the tower was 80 meter. Therefore if the shadow is 9 meter, what is height of the tree, right? Therefore, we are directly considering height of the tree is equal to 80 by 16 meter into 9 meter, right? Therefore, so 80 into 9, 720 by 16. So 720 is divisible by 16. 16 into 4, 64. 8 is the remainder. 16 into 5. Right? Height of the tree is 45 meters. Right? So compared to the shadow, height of the original object is more. Right? Therefore, here, so height of the tree is 45 meters. Option B is the right answer. So whenever in the question, it is given that this under the similar condition on the same time and day, so the object and its shadow. So two objects and their shadows are directly proportional. For example, we'll consider two objects A, B and C, D. They may be buildings, trees, towers, anything, right? So under the same condition, on the same time and same day, right? Same time of the day. So under this condition, the height of the two objects and their shadows. So we'll consider M, N and PQ as their shadows, right? Their heights are proportional. That means we can say AB by MN is equal to CD by PQ. They are directly proportional, right? Their ratios are same, right? Therefore, otherwise you can take MN by AB, shadow by object is equal to another shadow or height of the shadow by height of the object, right? Therefore, their ratios are equal, right? Ratio of their lengths are equal, ratio of their heights are equal. Anything you can consider. So therefore, for the given question, 45 meters, that is height of the tree, right? Option B is the right answer. Question number 8. 60 men could complete a work in 250 days. They worked together for 200 days. After that, the work had to be stopped for 10 days due to bad weather. How many more men should be engaged to complete the work in time? Students, to complete this, will consider two methods. One is the easiest method, or you can consider it as a trick, right? Another is theoretical method, right? So we'll consider the theoretical method first, right? In detail, we'll study this. So in the second method, the shortcut method, right? You can go for that. So later. So here it is given that 60 men could complete a work in 250 days. We all know that work is equal to efficiency into time, right? So the general formula for work is equal to efficiency into time. Here efficiency can be considered as number of persons working here. So 60 men are working here for 250 days to complete some amount of work, right? So we'll consider W as the amount of total work. Total work, BW, is equal to, so 60 men are working for 250 days to complete the work. They have to complete the work, right? So here they worked together for 200 days, right? So let us consider the amount of work done in 200 days, right? So work done in 200 days. In first 200 days, so let W1 be the work done by them means by 60 persons, 60 men in 200 days. This will be 60 men into 200. 60 into 200. Efficiency into time, right? So what is the remaining work here? Remaining work will be, so let it be W2, second half of the work, right? So in first half, not exactly half, in first part, so they worked for 200 days. Out of 250 days, they worked for 200 days. So what is the remaining number of days? 50 days are remaining, right? So in that, it is given that they had to stop the work for 10 days, right? Therefore, in 50 days, so we just subtract 10 days because they had to stop their work. Therefore, in the remaining 40 days, how many men are required, right, to complete this remaining work in time, right? Therefore, in the remaining 40 days, how many persons are required to complete the remaining work? For that, we need remaining work, right? What is the remaining work? Total work W minus the first part of the work. So 60 into 250 minus 60 into 200, we can take 60 as common. 250 minus 200. Therefore, it is 60 into 50. So 3000 units is the remaining work. It may be joule, right? Here also in the two different conditions, total work and the first part of the work. So we'll consider 60 into 250 units, 60 into 200 units. Therefore, the remaining work is 3000 units, right? So this remaining work should be completed in how many days? In 40 days, because they had to stop their work for 10 days. Therefore, number of men required, right, to complete in for the remaining work, you can mention complete the remaining work in 40 days. Remaining days are 40 is equal to, so again by the formula, work is equal to efficiency into time. We need efficiency here, number of persons required, which is equal to work divided by time, right? Therefore, it is work divided by time. So what is the work, remaining work? It is 3000 units, right? So this much amount of work to be completed in 40 days, right? Therefore, number of persons required is nothing but, so 4 into 7, 28, 4 into 5. So 75 days are required, right, to complete the remaining amount of work. So the question is, so how many more men should be engaged? So sorry, 75 persons, not days. 75 persons are required to complete the remaining work. In that, already 60 men are working, right? How many more? So number of persons required more, extra people required is nothing but, so actually 75 persons are required. In that, 60 are already working. So 15 more persons are, 16 more men are required to complete the remaining work. So that means extra men are required to complete the remaining work. So option C is the right answer, right? This is the theoretical method, right? So in which first we need to find the remaining work, right? What is the remaining last part of the work to be completed? In that, so they have to stop their work for 10 days. In that, so the number of days they are working is 40 days. Therefore, number of persons required to complete remaining work is 75. 75 persons are required. And it is given that 60 persons are already working, right? Therefore, 15 more persons or 15 more men are required to complete the remaining work, right? Therefore, the answer is option C. So in the second method, so very easy method it is. So we'll consider number of men working, right? And for number of days. So we'll consider the second case. So in the ideal case means, so when they, in the second case, they had to stop their work for 10 days, right? So we'll consider they are working continuously, right? For 200 days, they work continuously, right? And in the remaining 50 days also, they are working, right? So in the ideal case, how many persons are working in two different situations? 60 men and 60 men, right? Continuously they are working to complete the total amount of work, right? Therefore, we'll consider in ideal case, how many persons are working? 60 men working for how many days? We just focus on the next part, right? So next part of the work, second part of the work, 60 men are working for 50 days to complete remaining work. Work is remaining work, W2 if you consider, right? But in the question, right, we need to consider number of men required. So which is X to complete the remaining work in how many days? In 40 days, right? Therefore, in two different situations, number of persons required, right? And number of days we have written here, right? Here, number of persons required is inversely proportional to number of days, right? So more number of persons means they require less number of time to complete the work. Less number of persons means if, for example, X is less, right? That means less number of persons require more number of days to complete the same amount of work. Therefore, number of persons required is inversely proportional to number of days, right? Number of days. Therefore, again by the formula, efficiency into time is work. Therefore, efficiency is equal to work by time. Therefore, efficiency is inversely proportional to time. Here in this case, efficiency is nothing but number of men required is inversely proportional to number of days here, right? So we'll consider the two different situations and ratio of number of persons here, right? So 60 by X we will consider ratio, right? 60 by X is equal to, since 60 is inversely proportional to 40, therefore we'll consider 60 is inversely proportional to 40 and X is inversely proportional to 50 days, right? Therefore, X is equal to, so 60 into 40 by 50. So 10 into 4, 10 into 5, 10 into, sorry, 60 into 40 by 50. Am I right? No. 60, yes, 40 by 50, right? 60 into 50 by 40 it should be. Therefore, 10 into 4, 10 into 5, 4 into 15. So X is equal to 75. So number of persons required in the second situation is 75, right? 75 is the answer. So the extra persons required, or how many more should be engaged to complete the work? 15 more, right? Question number 9. 16 men can complete a piece of work in 8 days. In how many days can 12 men complete the same piece of work? Here, students, we need to consider the total amount of work they are going to do first, right? So what is the total work? As we had discussed in the previous question, the work is equal to efficiency into time. What is efficiency? So in general case, efficiency is nothing but work done per unit time, right? Work done per unit time. In this particular case, 16 men. So it is nothing but their efficiency, right? So 16 into, they work in 10 days. They work for 10 days. Therefore, total work is 16 into 8. So which is 128 units is the total work, right? So in how many days 12 men can complete the same amount of work, right? So in the second case, if efficiency is equal to 12 men, efficiency is equal to 12 men, and work is equal to same. So work is equal to 128 units. So what is the number of days taken by them to complete the same amount of work? Therefore, time is equal to total work 128 divided by efficiency, right? So which is 128 means 12 into 10, 10 integer 8 by 12, right? So which is nothing but 10 integer, so 4 into 2, 4 into 3, right? 10 integer 2 by 3 number of days, right, will be taken by them. How many persons will be taken by 12 men to complete 128 units of work, right? So number of days taken by them is 10 integer 2 by 3 days, right? Therefore, option A is the right answer. Question number 10. The cost of 4 calculators and 2 stencils is 6,200 rupees. What is the cost of 10 calculators and 5 stencils? So here, so 4 calculators and 2 stencils cost is 6,200, right? So we'll make half of it, right? What is the cost of 2 calculators, which is half of 4, and 1 stencils, right? So if you take 2 calculators and 1 stencils, right, you can easily find the cost of 10 calculators and 5 stencils, because 10 is a multiple of 2, which is 2 into 5, whereas 5 is 1 into 5, right? If you get the cost of 2 calculator and 1 stencils as some rupees, so into 5 gives cost of 10 calculators and 5 stencils, right? Let us go one by one, right? Cost of 4 calculators and 2 stencils is equal to 6,200 rupees, right? Therefore, cost of half of 4, which is 2 calculators and 1 stencils is equal to 6,200 by 2. Half of this cost, which is 3,100 rupees, is cost of half of the numbers, right? So 2 calculators and 1 stencil, right? So we need cost of 10 calculators. Therefore, cost of 10 calculators and 5 stencils is equal to, so cost of 2 calculators is 3,100, 2 calculators and 1 stencil, right? Together it is 3,100 into 5 times, right? 5 times its value. Because, so 2 into 5 is 10, 1 into 5 is 10, 5, right? Therefore, so the cost of 2 calculators and 1 stencils into 5 gives the required value. So here 5 into 1, 5 into 3. So 15,500 rupees is cost of 10 calculators and 5 stencils. So option A is the right answer. Question number 11. The cost of 18 packets, each having 20 toffees, is 300 rupees. What will be the cost of 114 toffees? So before going to consider the cost of 114 toffees, we have to take cost of 1 toffee, right? Cost of 1 toffee. So how to find cost of 1 toffee? Here cost of 18 packets is given. What is the cost of 1 packet? First we need to find. In 1 packet, there are 20 toffees. What is the cost of each toffee? We need to find. Then easily you can find cost of 114 toffees, right? So we'll consider 18 packets, toffees packets, right? There are 18 packets. And cost of 18 packets is 300 rupees. Right, we'll consider cost of 18 packets is equal to 300 rupees. What is the cost of each packet, right? So we'll consider cost of each one packet, right? Each packet is equal to 300 by 18, right? So you will get 6 into 3, 6 into 50, right? So 50 by 3 rupees is cost of each packet. In each packet, there are 20 toffees, right? What is cost of each toffee? Each toffee is equal to, so total cost of each packet is 50 by 3 rupees, right? There are 20 toffees in each packet. Therefore, cost of each toffee is 50 by 3 whole divided by 20. Therefore, it is 50 by 3 into 20, which is 60. Or 5 by 6 rupees is cost of each toffee. What is the cost of 114 toffees, right? Therefore, cost of 114 toffees is equal to, so cost of each toffee, which is 5 by 6 rupees, into 114, right? So 6 into 1, 6 into 9, right? So 19 into 5, 95 rupees. So cost of 114 toffees is 95 rupees. Option B is the right answer, right? So here first, students, we need to find cost of one toffee. How to find cost of one toffee? First, we need to find cost of each packet. Since there are 18 packets, so totally they cost 300 rupees. So cost of one packet is 50 by 3 rupees, right? In each packet, there are 20 toffees, right? Therefore, cost of one toffee or cost of each toffee is 5 by 6 rupees. Therefore, cost of 114 toffees is 95 rupees. Option B is the right answer. Students, if you want to practice such questions, please visit our website www.examsnet.com. You can also download our app. The link is given in the description box. Question number 12. 27 identical machines running at the same rate can pack 228 bags in 1 minute. At this rate, how many bags can be packed by 54 such machines in thrice the time? Right? So in thrice the time means compared to the previous time, which is 1 minute. In thrice the time means 3 times 1 minute is in 3 times. How many bags can be packed by 54 such machines? And it is given that 27 machines, right, can pack 228 bags in 1 minute, right? So first let us consider the number of bags packed by 54 such machines, right? Then in 3 times, that means in 3 minutes, right? So in 3 minutes, how many bags can be packed by 54 such machines, right? We'll consider, so number of bags packed by 27 machines in 1 minute, which is equal to 228 bags, right? So number of bags packed by 54 such machines, right? Therefore, number of bags packed by 54 machines in 1 minute. In 1 minute, so it is 27 machines can pack 228 bags, right? So here 54 nothing but 2 times 20, 27, right? Therefore, it is 228 into 2. Or you can consider it as, so 27 machines can pack 228 bags. Therefore, 54 machines into 54 will give you the same result. So 228 into 2 is, so 456 bags. So 54 machines can pack 456 bags, right? And it is given that in 3 times the original time. That means in 3 minutes, right? So these 456 bags are for 1 minute. Therefore, number of bags packed in 3 minutes, right? This is 450 bags per minute. Therefore, 456 into 3, so which is, right, 1368 bags. Therefore, 54 machines can pack 1368 bags in 3 minutes, right? Therefore, option C is the right answer. Question 13. The cost of 15 notebooks, each consisting of 125 pages, is 690 rupees. What is the cost of 250 notebooks, each consisting of 84 pages? So in this question, students, let us find the cost of one page, right? What does one page cost? Because here 15 notebooks cost 690 rupees and each notebook consists of 125 pages, right? Using this information, you have to find cost of one page. Therefore, cost of 84 pages, because 84 pages make one book in the second case, right? Therefore, cost of one book or 84 pages, right? Then cost of 250 notebooks, right? So, cost of, how to find cost of one page? For that, we need cost of one book, right? So, we'll consider cost of one book. So according to the given information, 15 notebooks cost 690 rupees. Therefore, cost of one book is 690 by 15. So which is equal to 15 into 4, 15 into 6. 46 rupees, right? Cost of one book is 46 rupees. And each book consisting of 125 pages, right? Therefore, cost of one page, right? So for 125 pages, you are giving 46 rupees. Therefore, cost of one page is 46 by 125 rupees. Cost of one page, right? Therefore, the question is, what is the cost of 250 notebooks, each consisting of 84 pages? So we'll consider cost of 84 pages. 84 pages means in the second case, it is one book, right? So each consisting of 84 pages. So it is one book in the second case, right? So it is equal to 46. Cost of one page is 46 by 125. Therefore, cost of 84 pages. So multiplied by 84. So this much rupees. Cost of 84 pages. So that means cost of one book is 46 into 84 by 125. Therefore, cost of 250 notebooks. 250 notebooks. So, cost of one notebook is 46 into 84 by 125. Therefore, cost of 250 notebooks into 250, right? Very simple calculation. So, 125 into 2 is 250. So, we have 46 into 84 into 2. So 46 into 84 is equal to 3864, 3864 into 2. Into 2 gives 7728 rupees is cost of 250 notebooks, right? And each page costs how much? Each page costs 46 by 125 rupees, and cost of one book is 46 into 84 by 125, right? This is in the second case. Whereas in the first case, so cost of one book was 46 rupees because 15 books cost 690 rupees. Therefore, cost of one book was 46 rupees. So, cost of each page was 46 by 125 rupees, right? Therefore, the answer for the given question is 7728. Option C is the right answer, right? Am I right? 7728. So option C. Question number 14. 56 men can complete a piece of work in 24 days. In how many days can 42 men complete the same piece of work? So to complete the same amount of work, so 42 men, right? So how many days they are taking? For that, first we need what is that piece of work? What is work needs to be done here, right? We know that work is equal to efficiency into time. Efficiency, in this particular case, efficiency is nothing but number of persons working here, right? So it is given that 56 men can complete a piece of work in 24 days. Therefore, we can write work as 56 men into number of days they are taking. 56 into 24, we will get 1344 units. It may be joule, right? So 56 into 24, 1344 units is the total work, right? To complete the same amount of work, so 42 men can take how many days, right? So therefore, to complete same work, 42 men will take how many days? So number of days or time is equal to work by efficiency, right? So work by number of persons. So it is nothing but efficiency. Work is 1344 units by number of persons. In the second case, it is 42, right? So divided by 42 is equal to 32, right? Days. How many days? 32 days. Unit is days, right? Therefore, 42 men will take 32 days to complete 1344 units of work, right? Therefore, option B is the right answer. Question number 15. If 5 men or 9 women can do a piece of work in 19 days, then 3 men and 6 women will do the same work in how many days? So here, 5 men or 9 women can do a piece of work in 19 days. So we can consider 5 men is equal to 9 women. So efficiency of 5 men is equal to efficiency of 9 women. Therefore, we can write 1 man is equal to 9 by 5 women. Right? If 5 men is equal to 9 women, 1 man is equal to 9 by 5 men. Right? Therefore, it is given that 5 men or 9 women can do a piece of work in 19 days. Right? So let the work be W. Let the total work be W. Work be W units. As in the previous example, here also we are using work is equal to efficiency into time. Efficiency into time. Right? Here total work is W units. So here efficiency is nothing but, so 9 women can do a piece of work in 19 days or 5 men can do a piece of work in 19 days. Either we have to consider 5 men or 9 women. Right? So I'll consider 9 women is the efficiency. Right? And number of days taken is 19 days, or you can consider 5 men also, right? So 9 women into 19, so 171 units is the total work, if it is so, right? Then 3 men and 6 women will do the same work in how many days? So that means in the second case, so 3 men and that means plus how many women? 6 women. 3 men and 6 women, right, will do the same amount of work, which is 171 units of work. In how many days? Let D2 be the number of days. Therefore, the formula efficiency into time is equal to work. Right? Here, number of days taken by 13 men, not 3, 13 men and 6 women. So 13 men and 6 women, it is the efficiency into number of days is D2 is equal to same amount of work, which is 171 units. Here we need to find number of days taken by 3 men and 6 women. So 3 men, not 13, sorry. 3 men and 6 women. So for that, we'll use the relation between efficiency of men and women. It is given that 5 men is equal to 9 women. So we'll consider 1 man is equal to 9 by 5 women, right? Substitute that value. 3 men becomes 3 into 9 by 5 women, right? Plus 6 women into number of days taken by them is equal to 171. So we'll consider 5 as LCM and the numerator becomes, so 9 into 3, 27 women plus 6 into 5, 30 women into D2 is equal to 171. Therefore, D2 is equal to 171 into 5 divided by this part 27 plus 30 is 57. Since 57 into 3 is 171, 5 into 3 is 15. Therefore, 3 men and 6 women will take 15 days of time to complete same amount of work. Right? So, they'll take 15 days of time to complete same amount of work. Hence, option C is the right answer. Right? So, in this question, first we need to relate the efficiency of men and women here. It is given that 5 men or 9 women can do a piece of work in 90 days. 5 men will take same number of days to complete some amount of work. And also, 9 women will take same number of days. Therefore, the respective efficiencies are equal, right? Therefore, 1 man is equal to 9 by 5 women. Keeping this in our mind, right? You can go for the total work. How to find total work? Efficiency into time. Either you can take efficiency of men or women, right? You will get the same answer, right? Now, total work needs to be calculated. So, which is 171 units. And in the second case, 3 men and 6 women, right? How many days they are taking? Just substituting the values of efficiency of men and women, you will get the answer, right? So, finally, we got 15 days of time as the answer, right? Option C. Question number 16. 3 pumps working 8 hours a day can empty a tank in 2 days. How many hours a day must 4 pumps work to empty the tank in 1 day? So, students, let us consider a tank. To empty the tank, 3 pumps need to work, right, for 2 days. 3 pumps need to work for 2 days. And in each day, 8 hours each pump has to work, right? Therefore, here to empty the tank, what is the work needs to be done? To empty, the work needs to be done is equal to, here again we are following the same formula, efficiency into time, right? Efficiency into time. Here efficiency is nothing but work done by 3 pumps, right? Right? In how many hours? 8 hours for 2 days, right? Therefore, here the time is 2 days, and for in every day, each pump work for 8 hours. Therefore, the product of 3 pumps, 2 days and 8 hours gives the total work needs to be done to empty the tank, right? Therefore, it is 3 into 2, 6, 6 into 8, 48 units is the total amount of work, right, to empty the tank. Therefore, the question is, how many hours a day must 4 pumps work to empty the tank in 1 day? So, to empty the tank means same amount of work needs to be done, right? Therefore, so 4 pumps, 4 pumps in 1 day, how many hours they need? How many hours 4 pumps need to work? That means D2 hours. If they work, they can empty the 4 pumps can empty the tank. That means amount of work is 48 units. Right? Therefore, D2 is equal to 48 divided by 4 into 1 day. So, which is 4. Therefore, so each pump has to work for how many hours? 12 hours. Right? So each pump has to work for 12 hours a day. Right? Only one day 4 pumps are working to empty the tank. Therefore, each pump has to work for 12 hours. Then only 4 pumps can empty the tank in only one day. Right? Therefore, option A is the right answer. I'll repeat once again. It is given that 3 pumps can empty the tank in 2 days and each pump has to work for 8 hours in a day. Then only 3 pumps can empty the tank in 2 days, right? Therefore, the total work needs to be done to empty the tank is product of these 3 values, because work is efficiency into time and the time is already given, the product of days and hours, 2 days and 8 hours, and the 3 pumps is nothing but the efficiency, right? So it is 48 units. The total work to empty the tank is 48 units. To empty the same tank, if four pumps start working only for one day, how many hours they need? Therefore, the product of number of pumps, number of days, and number of hours, which is nothing but efficiency into time, gives the total work. Here, the total work is same, right? Therefore, number of hours, right? Number of hours D2 is equal to 12 hours, right? In one day, each pump has to work for 12 hours, right? Therefore, option A is the right answer. Question number 17. A fort has provision for 50 days. After 15 days, a reinforcement of 150 men arrives and the provision now lasts 25 days. How many men were there in the fort? So let us consider X as number of men in the fort, right? So number of persons be X, right? So fort has provision for 50 days, right? So provision for 50 days. So the total provision for 50 days is equal to, so number of persons into number of days, right? So number of persons X into 50 is 50X is the total provision for 50 days. Since we are using the concept of efficiency into time as the total work, here provisions to be provided is considered as work. Since we have discussed in the previous question, yes, work is equal to efficiency into time. We are using this concept. Here provisions to be provided is considered as work, right? And number of persons, right? Number of persons, which is X, is considered as their efficiency into time. For how many days these provisions last? For 50 days, right? Therefore, the time is 50 here. Therefore, total provision for 50 days is 50 into X, right? So for first 15 days, right, it is given that for first 15 days, number of men in the fort were X, right? For first 15 days, right? Therefore, 15 into X provisions were provided for 15 days, right? And 150 men were reinforced after 15 days, right? And the provision now lasts for 25 days, right? After 15 days, 150 men arrived, right? So the number of persons becomes X plus 150 and provision, so the remaining provisions last for 25 days, right? After 15 days, remaining provisions last for 25 days. So here the question is, how many men were there in the fort, right? So very simple question. Here, total provision is equal to provision for first 15 days, right? First 15 days plus provision for last 35 days can be considered. Instead of last 35 days, since number of men is increased here, right? Therefore, the last 35 days is reduced to 25 days, right? Therefore, provision for X plus 150 persons. X plus 150 persons, right? So more the number of persons, less will be number of days, right? If persons are more, so provisions will last for less number of days. If number of persons is less, so provisions will last for more number of days, right? So here total provision is 50 into X. Provisions for first 15 days is does nothing but number of persons into time, efficiency into time. So there were X number of persons for 15 days, right? Plus there were X plus 150 persons for 25 days, because provisions last only for 25 days after 15 days, right? It is directly given in the question. Here we need the value of X. How many men were there in the fort? So what is the value of X? So simplification part. So here 50X. So minus 15X. We'll take this 15X to the left hand side. So here it becomes 25X plus 25 into 150. So it is 35X minus 25X. Take this 25X to the LHS. It becomes 25 into 150. So 10X is equal to 25 into 150. So value of X becomes 25 into 15, right? So 25 into 15 is 375, right? So value of X is 375. There were 375 men were there in the fort for first 15 days, right? Then it is increased, number of men is increased, right? So here 375 plus 150 after 15 days. So the number of men was 375 plus 150 is 475, 525. It was increased to 525, right? Therefore, look at the options. Here, there is a small correction in option C. It should be 375, right? Option C is the right answer. Number of men in the fort were 375. This is only for first 15 days, right? Option C is the right answer. Question number 18. If 7 spiders make 7 webs in 7 days, then in how many days one spider will make 1 web? Here, students, it is given that, so to make 7 webs, 7 spiders take 7 days of time, right? 7 spiders take 7 days of time. Therefore, to make one web, so one spider will take how many days, right? So 7 to make 7 webs. So there are 7 spiders, right? So to make only one web, so one spider will take complete 7 days, right? So one spider will take complete 7 days. Since number of days, number of webs and number of spiders are in the ratio 1:1:1, right? These numbers are in the ratio 1:1:1. Therefore, one spider will take complete 7 days to complete one complete web, right? Therefore, the answer is option A. Question number 19. Matthew takes a picture of a 1-meter snake that was seen beside a brick wall. When he developed his picture, the 1-meter snake appears 2 centimeter long and the wall appears 4.5 centimeter high. The actual height of the brick wall is. Here, students, it's an easy question. So he takes a picture of 1-meter snake that was seen beside the brick wall. So we'll consider a brick wall, right? Brick wall. And he takes the picture of a snake. So we'll consider this as a snake, right? And he developed his picture, the 1-meter snake appears 2 centimeter long. So we'll consider the picture of the snake, which is 2 centimeter. Here 2 centimeter is nothing but image of the snake, right? Image of the snake appears 2 centimeter long and the wall appears 4.5 centimeter height. So that means image of the wall which he develops is 4.5 centimeter height. Right? Here we need to find actual height of the brick wall. Let x centimeter be the actual height of the brick wall. And the length of the snake was 1 meter. 1 meter is nothing but 100 centimeter. Since all the images and height of the wall are in terms of centimeter, so it is better to express the length of the snake also in terms of centimeter, right? Here we need to find actual height of the brick wall. Here, students, the ratio of length of the snake, actual length of the snake and image of the snake, right, is equal to ratio of height of the wall to the image of the wall, right? So because the same person develops in the same ratio here. When he develops his picture, so 1 meter snake appears 2 centimeter long. In the same picture, he gets the image of the wall also. So the ratio of the original height and length of the given pictures, wall and snake, right, to the ratio of their respective image will be same, right? Because both the images he gets in the same picture here, right? Therefore, so ratio of original picture or original picture to the image. So ratio of original pictures to the images are same. Here original pictures are, right, or original things are snake and walls, right? Therefore, so length of snake to its image is equal to height of wall to its image, right? Length of snake is 100 centimeter and its image is 2 centimeter, and height of wall, so according to our assumption, it is x centimeter, and its image he develops is 4.5 centimeter. Therefore, x is equal to, so 100 by 2 is 50 centimeter into 4.5. You will get 225 centimeter as a height of the wall, right? Height of the wall is 225 centimeter. Here, the simple logic is, as he gets the images of wall and snakes in the same picture, so the ratio of their original things, right, things given to their respective images are same, right? Therefore, actual height of the brick is 225 centimeter. Question number 20. In a camp, there are suitable arrangements for 75 men or 90 children. If 42 children are attending the camp, then how many men can join the camp? So in a camp, students, 75 men or 90 children. 90 children, there are for them suitable arrangements are made, right? Either for 75 men or for 90 children, not together, right? So it is given that 42 children are attending the camp. So 42 children are attending the camp means how many more children can join here? So the remaining children can be joined is equal to 48, right? Because totally there can be 90 children, right, in a camp. Suitable arrangements are for 90 children. Already 42 children are attending. How many more children can be joined here? 48 more children can be joined. Here the question is, how many men can join the camp? So instead of 48 children, right, how many men can join the camp? For that, so we have to consider one child is equal to how many men, right? How many men? Using the given relation, so 75 men is equal to 90 children, because the suitable arrangements are, right, the arrangements are suitable for 75 men or 90 children. These arrangements are, that means full for 75 men or 90 children. Therefore, we can equate the capacity of 75 men is equal to capacity of 90 children, right? Even you can mention capacity capacity of 75 men is equal to capacity of 90 children. Therefore, one child is equal to 75 by 90 men. Right? So 75 and 90 are the multiples of 15. So 15 into 5, 15 into 6. So one child is equal to 5 by 6 times a man. Right? 5 by 6 times a man. Therefore, here we have to convert 48 children or capacity of 48 children. The remaining children can be attended here or can be joined, right? So 48 children in terms of number of men here, right? Therefore, 48 children is equal to. So one child is 5 by 6 man. So 5 by 6 into 48, right? So one child is equal to 5 by 6 man. Therefore, 48 children is equal to 6 into 8. Therefore, 48 children is equal to 40 men. So instead of joining 48 children, we can join 40 men to the camp. 40 men to the camp. Therefore, how many men can join the camp? 40 men can join the camp so that there are suitable arrangement for them, right? Therefore, option D is the right answer. Question number 21. 60 meters of a uniform wire weighs 80 kg. What will 141 meters of the same wire weigh? So an easy question. Here to find 141 meters of the same wire, we need what is the weight of 1 meter wire, right? So 60 meters of a uniform wire weighs 80 kg, right? So weight of 60 meters wire. 60 meters wire is equal to 80 kg. Therefore, what is the weight of 1 meter wire? Since the wire is a uniform wire, right? Uniform wire means its volume in each area is same, right? So, weight of 1 meter wire will be 80 by 60 kg, which is nothing but 4 by 3 kg. So, this is weight of 1 meter wire. Therefore, what is the weight of 141 meters wire? So 1 meter wire weighs 4 by 3 kg. Therefore, weight of 141 meters wire, right? Therefore, it is 3 into 4, 3 into 7, right? 3 into 47 is 141. So 47 into 4 is 188 kg. So weight of 141 meters wire is 188 kg. Option C is the right answer. Students, if you want to practice such questions, please visit our website www.examsnet.com. You can also download our app. The link is given in the description box. Question number 22. 15 persons complete a job in 3 days. How many days will 10 persons take to complete the same job? Here, students, we are using the simple logic here. So, more persons are 15 persons here. So, 15 persons, if they take 3 days of time to complete a work. So, what about 10 persons? Here are less persons compared to 15 persons. In the second case, there are less persons. They have to take more number of days to complete the same job. They have to take more number of days, right? Therefore, here, if 15 persons take 3 days of time to complete the job, so let the job be any work, right? We'll consider it as W, right? So, W as the work. We know that work is always efficiency into time. In general case, or general formula for work is efficiency into time, right? To complete a work, so let W1 be the work to be completed. 15 persons are taking 3 days of time. Here, time is nothing but 3 days of time, and efficiency is nothing but number of persons we are considering, right? So, how efficient or how many persons are engaging in the work, right? So, 15 persons are taking 3 days of time to complete the work. Therefore, 15 into 3 days, which is 45 units, is the work they are going to finish, right? So 45 units is the work. To complete the same work, how many days 10 persons are taking, right? So here, to complete W1 units of work, so 10 persons are taking D2 number of days, right? What is the work here? 45 units is equal to 10 into D2. Therefore, D2 is equal to 45 by 10. So 5 into 9, 5 into 2. So 9 by 2 number of days they are taking. That 4 integer, 1 by 2 days. So 10 persons are taking 4.5 days of time to complete the same amount of work, which is 45 units, right? So compared to the previous case, so 15 persons took 3 days of time, whereas 10 persons took 4.5 days, more number of days, right? Therefore, option D is the right answer. Question number 23. A certain number of men can finish a piece of work in 100 days. If there were 10 men less, it will take 10 days more for the work to be finished. How many men were there originally? So students, as in the previous question, here also using the concept of work is equal to efficiency into time. In this particular case, here efficiency is nothing but number of persons, right? So here, certain number of men can finish a piece of work in 100 days. So this number of men be X. There are X number of men who are going to finish a work in 100 days. So we'll consider initial work done by X number of men. Consider this part. Initially, X men are going to finish a work in 100 days. And in the second case, if there were 10 men less, it will take 10 days more for the work to be finished. That means to complete same work, right? So if there were 10 men less, right? To complete same work, that means final work is equal to initial work, right? So first equate initial work is equal to final work, right? Where the number of men and number of days are different, right? Accordingly, we are applying the formula of work is equal to efficiency into time. In initial work, there were X number of men, right? Work is equal to efficiency is nothing but number of persons, right? X into time. They took 100 days of time to complete the work, right? X men into 100 days is equal to, right? In the final case, in the final work, if there were 10 men less, means 10 men less means X minus 10 men less. It will take 10 days more for the work to be finished. 10 days more means initial number of days plus 10 number of days. 100 plus 10 days. Then both the initial and final works will be same, right? So here the question is, how many men were there originally? So we need to find the value of X, right? So simplify it. So 100 into X, 100X is equal to X minus 10 into 110, right? Which is equal to 110X minus 1100. So after simplification, you will get 10X is equal to 1100. So value of X is equal to 110, right? So initially there were 110 men, right? To complete the initial work in 100 days, right? So option A is the right answer. Whereas in the final work, so X minus 10 number of men, that means 100 men, they took 110 days, 100 plus 10 days, right? So that the work will be same, right? Therefore, option A is the right answer. Question 24. A wheel that has 6 cogs is measured with a larger wheel of 14 cogs. When the smaller wheel has made 21 revolutions, then the number of revolutions made by the larger wheel is. So students, let us consider a smaller wheel which has 6 cogs. So cog is nothing but it's a tooth on a wheel, right? So we'll consider 6 cogs. 1, 2, 3, 4, 5 and 6. Right? Smaller wheel has 6 cogs. It is meshed with a larger wheel of 14 cogs. We'll consider a larger wheel which has 14 cogs. 1, 2, 3, 4, 5, 6 and 7, 8, 9, 10, 11, 12, 13 and 14 cogs. So larger wheel has 14 cogs, right? Whereas smaller one has 6 cogs. So when the smaller wheel is meshed with a larger wheel, right? When smaller wheel has made 21 revolutions, right? So what is the number of revolutions made by larger wheel, right? So here for to complete one complete revolution, right? The smaller wheel, right? In smaller wheel, so each cog has to cross one cog from the larger wheel. When the first cog, if you consider this as first cog, is in contact with the first cog of the next wheel, right? So when it is making a revolution, so it has to push the first cog of next wheel, right? So in place of first cog, second cog comes, right? When it pushes simultaneously, both the wheels are rotating here, right? So if this wheel is rotating in this direction, right? So next wheel will rotate in anti-clockwise direction, right? So for one complete rotation, all 6 cogs, right, have to cross 6 cogs of the next wheel, right? So if you consider 1, 2, 3, 4, 5, 6, right? So the 6 cogs of the smaller wheel have to pass 6 cogs of second wheel, right? The larger wheel, right? So this completes one revolution of the smaller wheel. So there are 21 revolutions, right? So how many cogs they will push, right? While completing 21 revolutions, how many cogs they will push or they will pass, right? So we'll consider number of cogs pushed by smaller wheel in 21 revolutions. 21 revolutions. In one revolution, smaller wheel pushes 6 cogs, right? Therefore, in 21 revolutions, so it crosses or it pushes 126 cogs, right? There are 14 cogs in one revolution of the larger wheel, right? 14 cogs. Therefore, number of revolutions by larger wheel is equal to, right? To complete one revolution, so it has to pass or it has to push 14 cogs for one complete revolution. So if there are 126 cogs, how many revolutions are made by larger wheel? So it is 9 revolutions, right? 9 revolutions. Therefore, so look at the options. Option C is the right answer. So number of revolutions made by the larger wheel is 9, right? Very simple calculation. Option C is the right answer. Question number 25. A piece of work can be done by 34 workers in 15 days. How long will 51 workers take in order to do the same work? So in order to do a work, 34 workers take 15 days of time, right? Therefore, 51 workers take how many days? So here compared to 34, 51 is more, right? More number of people, more number of workers take less time compared to the previous time. Therefore, number of days will be less than 15 days. Less than 15 days. According to the options, all the options are less than 15 days, right? So let us go to the theoretical method here. Students, here we are going to use the concept of work, right? So work is equal to efficiency into time. Efficiency into time. So in this case, efficiency is nothing but number of persons, right, who are going to work. So here, number of persons into time is nothing but how many days they are going to take to complete the work, right? So in first case, work done is equal to, so 34 workers took 15 days of time. Therefore, work is equal to 34 into 15. Right? So how long will 51 workers take in order to do the same work? So in the second case, work is same amount of work needs to be done, which is 34 into 15, right? By how many persons? 51 persons, right? So here number of persons is equal to 51 into number of days. So in how many days? Let D be the number of days taken by 51 workers, so that we can equate both RHS parts. Since work is same, so we can equate 51 into number of days taken by 51 workers is equal to 34 into 15. Simplify it. D is equal to 34 into 15 by 51. Right? So here, both the numbers are divisible by 3. 3 into 17, 3 into 5, and 17 into 2 is 34. So 51 workers took 10 days of time to complete the same work. Option C is the right answer, where 10 days is nothing but less than 15 days, right? So 51 workers took less number of days compared to the previous case, right? So for the given question, option C is the right answer. Question 26. A car manufacturing plant manufactures 96 dozen cars in 8 days. How many dozen cars will the plant manufacture in 17 days? So in 8 days, it manufactures 96 dozens. So in one day, how many cars it manufactures? First, we need to find. Therefore, in 17 days, right? So car manufactured or cars manufactured in one day. Manufactured in one day. In 8 days, they manufacture 96 dozen. Therefore, in one day, they manufacture 96 by 8 dozen cars. So, which is 12 dozen cars they manufacture. Right? Therefore, in 17 days, how many cars they manufacture? 12 dozen into 17. Right? Therefore, it is 34. 204 dozen cars they manufacture. Right? In 17 days, they manufacture 204. Option C is the right answer. Question number 27. The price of 3 chairs and 4 tables is 20,500 rupees, and the price of 4 chairs and 3 tables is 18,000 rupees. What is the difference between prices of one table and one chair? So this question is based on simultaneous linear equations, right? So we have to solve the question based on simultaneous linear equations. Right? Simultaneous linear equations. How to solve this equation? For that, let us consider the prices of one table and one chair as X and Y, right? X and Y respectively. So, price of one chair be X rupees, and price of one table be Y rupees. Right? And it is given that price of 3 chairs and 4 tables is 20,500. Therefore, 3 chairs price plus 4 tables price, 4 into Y becomes 20,500 rupees. And price of 4 chairs. So price of each chair is for X rupees. 4 chairs becomes 4 into X rupees plus 3 tables. 3 into y becomes 18,000 rupees. So we have got two, that means simultaneous linear equations, right? Having the degree, having the power 1, x raised to 1 and y raised to 1. Therefore, how to solve two simultaneous linear equations? So first we need to convert the coefficient of one of the unknown factor as same, right? Here x has its coefficient 3 in first equation, y has its coefficient 4 in second equation. Convert their coefficients the same, right? For that, let us multiply first equation by 4, second equation by 3, right? You will get first equation as 12x plus 16y is equal to, so RHS should be multiplied by 4. You will get 5 into 4, 20. Then 82,000 as RHS. So we'll consider this as again first equation. And the second equation becomes, when it is multiplied by 3, 12x plus 3 into 3y is 9y is equal to 54,000. Right? This is the second equation. So we just subtract one equation from another, right? So equation 2 from 1. So you will get 16 minus 9, which is 7y, is equal to 82 minus 54. You will get 28,000. So y becomes 4,000. What is y? According to our assumption, y be the price of one table, right? So it is price of one table. How to get value of x? Substitute a value of y in any of the given equations. Even you can consider this given equation, 3x plus 4y is equal to 20,500, right? So that makes no difference. So substitute. So equation 1 becomes any equation you can consider. So we'll consider this equation, right? So equation 1 becomes 12x plus 16y. 12x plus 16 into y is 4,000 is equal to 82,000. Right? 82,000. Simplify it. 12x is equal to 82,000 minus 16 into 4,000. So 64,000. Right? So 74. So you will get 18,000. Therefore, value of x is, so 18,000 by 12, right? So 12 into 1, 12 into 5, 1,500 rupees is price of a chair, value of x, right? Here the question is difference between prices of one table and one chair. Difference between prices of one table and one chair means either x minus y or y minus x. Here y is greater, right? Therefore, y minus x, difference between prices of one table and chair is 4,000 minus 1,500, which is 2,500 rupees, right? So difference between price of one chair and one table. Option B is the right answer. Question number 28. Running at the same constant rate, 6 identical machines can produce a total of 270 bottles per minute. At this rate, how many bottles could 10 such machines produce in 4 minutes? So here, students, it is given that 6 machines can produce a total of 270 bottles per minute, right? So we'll consider 6 machines in 1 minute. In 1 minute, they produce how many bottles? 270 bottles. Totally, 6 machines produce 270 bottles per minute, right? We need to consider, so 10 such machines in 4 minutes, right? Before going to 10 machines, so how many bottles can one machine produce in 1 minute, right? So in one machine in 1 minute, how many bottles it can produce? So we'll consider one machine in 1 minute. If 6 machines can produce 270 bottles, one machine can produce 270 by 6 bottles, which is nothing but 6 into 4, 6 into 5. So one machine can produce 45 bottles in 1 minute, right? So we'll consider 10 such machines. Therefore, 10 machines in 1 minute. We'll consider in 1 minute first. Later we can go for 4 minutes, right? So 10 such machines can produce 45 into 10 bottles, right? So which is 450 bottles, right? Therefore, these 10 machines in how many minutes? According to the question, in 4 minutes. They can produce 450 bottles into 4 minutes. In 1 minute, if they can produce 450 bottles, in 4 minutes, they can produce 450 into 4, which is 1800 bottles. Right? This is how you have to solve such type of questions. First, we need to find number of bottles produced by one machine in 1 minute. Right? So that you can easily take the product of the respective numbers, such 10 such machines and 4 minutes, right? Just we are multiplying those numbers here, right? Therefore, the given question, option C is the answer, right? So in 4 minutes, 10 machines can produce 1800 bottles. Question 29. If 15 men can do a certain amount of work in 20 days, working 8 hours a day, in how many days will 10 men do 3 times the work, working 6 hours a day? So students, we are using the concept of work here, so which is equal to efficiency into time. Efficiency into time. If the work done needs to be 3 times the original work, right? Here, originally 15 men did a work in 20 days and in each day they work for 8 hours, right? So to do some amount of work, right? So to do the 3 times the original work, 3 times the original work, so 10 men will take how many number of days we need to consider, right? And given that if they work 6 hours a day, how many days they are going to take to complete the work, right? Here the work is not same in both the situation. In the second situation, work is 3 times the original work, right? So for that, we need to consider the original work done, right? Here work is efficiency into time. Efficiency is nothing but number of persons who are going to work, right? Therefore, we'll consider original work. Original work is equal to efficiency is nothing but number of persons into time, right? Into time. So how many persons are working originally? 15 men were working originally, right? And they work for 20 days. It is not only the number of days, and in each day they work for 8 hours. Therefore, 20 into 8. Right? 20 days into 8 hours. Right? This gives the whole time. Therefore, the original work is, so 15 into 20, which is 300 into 8. So, which is equal to 2400 units is the original work. Right? And the final work is 3 times the original work. Right? So, to do the final work, we are using the same formula, right? So efficiency into time. So some number of persons were working, right? So 10 men work for how many number of days? So number of persons, final work is equal to number of persons into time, right? To complete the final work, 10 men work for D number of days, right? D number of days, right? And in each day, they work for 6 hours. It is already given. They work for 6 hours. And the result is the final work, which is 3 times the original work. Final work is 3 times the original work, right? So we substitute the values. Original work is 2400 units into 3 is equal to 10 into 6 into, let D be the number of days they are going to take. Therefore, D is equal to, so here 3 into 2400 is 7200 by 60. 10 into 6 is 60. Therefore, So 6 into 12 and 0. So 10 men took 120 number of days to complete 3 times the original work, and provided they work for 6 hours a day. Right? Therefore, 120 days is the answer. Look at the options. Option A is the right answer. Question number 30. A contractor undertook to complete a project in 90 days and employed 60 men on it. After 60 days, he found that 3/4 of the work has already been completed. How many men can he discharge so that the project may be completed exactly on time? So students, let us understand the question first. So a contractor undertook a project and his aim is to complete the project in 90 days. Right? In 90 days, he has to complete the work. In that, so in 60 days, he completed 3/4 of the total work. Right? So we'll consider total work as X units. That the total work is X units. Right? 3/4 of the work has been completed in 60 days. Therefore, in 60 days, we'll complete work as 3/4 into X. Right? In 60 days, it is completed. So how many persons are working here? He hired how many persons? He hired 60 men. So 60 men are working for 60 days to complete 3/4 of the work. Right? Therefore, here students, as in the previous case, here also we are using the concept of work, which is efficiency into time. Efficiency into time. So in this particular case, efficiency is nothing but number of persons working, or capacity of persons is considered as efficiency, right? So number of persons into number of days they are going to take, right? So in first case, so we can say 3/4 of total work. 3/4 of total work is equal to, right? So to complete total work, they took 60 days of time. How many persons are working? 60 persons are working. Right? What is total work? According to our assumption, it is X units. Right? Therefore, 3/4 of X units is equal to 60 into 60, which is 3,600. So using this relation, you can find the total work. Why do we need total work? To find the final answer. How many men can be discharged so that the project may completed exactly on time. So in the remaining 1/4 of work, right? How many persons are required? How many persons are required? Based on this value, you can answer the question. How many men can he discharge so that the project completed exactly on time, right? Therefore, first we need to find what is the total work, right? So that you can find the remaining work and the remaining persons required to complete the remaining work, right? So therefore, X is equal to 3,600 into 4 divided by 3. Therefore, it is 3 into 1,200. So 4,800 units is the total work. Here the value of X is 4,800 units. In that, what is the remaining work? Therefore, remaining work is equal to only quarter of total work. 1/4 of the total work is remaining. Therefore, 4,800 by 4, which is equal to 1,200 units is the remaining work, right? Which is nothing but, according to the concept, number of persons to complete the remaining work into the time, number of days they are going to work. So remaining days are only 30 days, right? So in 60 days, they had completed 3/4 of the work. In the remaining 30 days, right? Therefore, remaining days are 30 days, and number of persons required, let P be the number of persons required, into 30 gives 1,200 units. Therefore, P is equal to 1,200 by 30, which is equal to 40. So 40 persons are required to complete the remaining work. right? But here the question is, how many men can he discharge? So already 60 men are working. They worked for 60 days. 60 men worked for 60 days. But to complete the remaining work, only 40 men are required. Therefore, he has to discharge 60 minus 40, 20 persons, right? Therefore, so to complete remaining work, 40 men are required for remaining work. Therefore, so number of persons he has to discharge is equal to, already 60 men are working, in that he needs only 40, therefore he has to discharge 20 men, right? Therefore the work completes exactly on time, right? Therefore option B is the right answer. Question number 31. 20 men complete 1/3 of a piece of work in 20 days. How many more men should be employed to finish the rest of the work in 25 more days? So students, as in the previous question, here also we are using the same concept of work, which is equal to efficiency into time, right? Efficiency into time. Here efficiency is nothing but capacity of number of persons, right? So number of persons into how many days they are going to take to complete the work. So which gives the total work, right? So let us assume the total work be X units, right? So let it be X units. So here 20 men complete 1/3 of a piece of work in 20 days. So if you consider total work as X units, right? In that 1/3 of work, so this completes 1/3 of work, right? So 1/3 of work means 1/3 into X, right? Has been done by 20 men in 20 days. Therefore, 1/3 of work is equal to 20 into 20, right? Therefore, we'll consider 1/3 of work is equal to 20 into 20. Efficiency or number of persons into number of days. Therefore, 1/3 into X is equal to 20 into 20. Therefore, X is equal to 20 into 20, which is 400, into 3, which gives 1200 units. What is X? According to our assumption, X is the total work, right? Therefore, X units is equal to how much? 1200 units is the total work, which is total work. Here the question is, how many more men should be employed to finish the rest of the work? What is the remaining work? Rest of the work is equal to, so total work, which is X minus 1/3 of work, which is equal to 2/3 of the total work. 2/3X is rest of the work, right? So to complete rest of the work in 25 more days, in 25 days, how many men should be employed, right? Therefore, we'll consider rest of the work is equal to number of persons into number of days. So in how many days they are going to complete rest of the work? 25 more days, right? So number of days taken to complete rest of the work is 25, and number of persons. So we'll consider number of persons into 25. What is rest of the work? It is 2/3X, 2/3 of X, right? So 2/3 of X is rest of the work, but X is total work is 1200 units, which we have already calculated. 2/3 into 1200 is equal to persons required to complete rest of the work into 25 days. Simplify it. Therefore, number of persons required is equal to, so here 3 into 4 is 12, so 3 into 400. 400 into 2 is 800. 800 by 25 is number of persons required, right? So 25 into 3 is 75, 25 into 2. So 32 persons are required to complete rest of the work, right? I'll come back here. So to complete rest of the work, 32 persons are required. Here the question is, how many more men should be employed? Already 20 persons are working, right? 20 men complete 1/3 of the work. Already they are working, but to complete the remaining work, 32 persons are required. Therefore, more number of persons required is 32 minus 20, which is 12 persons. 12 more persons are required, right? So, more persons required. More persons required are, so 32 persons required to complete remaining work. In that 20 are already working. 32 minus 20 is 12 more persons are required. He has to hire 12 more persons to complete rest of the work, right? So option C is the right answer. Question 32. A tree 24.5 meter high of casts a shadow of length 56.35 meter. Find the height of a tower which casts a shadow of length 40.25 meter under similar conditions. Here under similar conditions, right? So we'll consider two objects, a tree and a tower, right? This is a tree and a tower, right? Here tree casts a shadow and also a tower casts a shadow, right? So height of the tree is 24.5 meter and its shadow of height 56.35 meter and shadow of the tower is 40.25 meter height. This is shadow of the tower, right? We need to find height of the tower. So let it be H. Right? So here it is given that under similar conditions, right? Under similar conditions means any other external conditions do not affect the height of the or the shadow, height of the shadow of two objects, right? Under similar condition means external factors do not affect the height of the shadow, right? That means the ratio of the real object to its shadow, right? So shadow is equal to ratio of another real object to its shadow, right? The ratio of the object to shadow, the two ratios will be same, right? Therefore, here the height of the tree is, so height of tree to its shadow is equal to height of tower to its shadow, This is how you can find height of the tower, right? Height of the tree is already given 24.5 meters and its shadow is 56.35 meter is equal to height of the tower is H and shadow is 40.25 meter, right? So you can simplify it. Here, let us round off each decimals into whole numbers, right? So here, 24.50 meter, I'll write it as 2450 centimeter. So meter to centimeter conversion. Whereas 56.35 meter can be written as 5635 centimeter is equal to H by 4025 centimeter, right? Therefore, height of the tower is 2450 into 4025 divided by 5635. So you can go for the multiplication of 5. Since both the numbers 4025 and 5635 divisible by 5, right? So 5 into 1, 5 into 1, 5 into 2, 5 into 7. Whereas the numerator becomes 5 into 8 and 5 into 5, right? So here 805 into 2450 gives 19,72,250 divided by the denominator part 1127. You will get 1750 centimeter as height of the tower. right? So in terms of meter, it is 17.5 meters, right? 17.5 meter is height of the tower. Option B is the right answer, right? So I'll repeat once again. It is given that under similar conditions, that means at the same time, right? Irrespective of any other weather conditions. So the external factors do not affect the shadow of two objects here, tree and tower, right? Therefore, the ratio of the object to its shadow is equal to ratio of another object to its shadow. Therefore, we have taken two ratios, right? This is how you can calculate height of the tower. Option B is the right answer. Question 33. A sheep can graze 1 square feet of land in 7 days. Then how many sheep will graze 7 square feet land in 7 days? So if you consider 7 square feet land like this, right? So 1 square feet, 2 square feet, 4 square feet, 6 square feet, and this is the 7th square feet land, right? There are 7 square feet lands, right? So in that 1 square feet land, right, is grazed by one sheep in 7 days. One sheep takes 7 days of time to graze 1 square feet of land. Therefore, to graze 7 square feet land in 7 days. So in 7 days, if you consider one more square feet of land, one more, there are 7 square feet land, right? Will be grazed by 7 sheep. 7 sheep, right? Therefore, option B is the right answer. So 7 square feet land will be grazed by 7 sheep in 7 days. In 7 days. Therefore, option B is the right answer. Question 34. If the cost of X pence is Y rupees, then what is the cost of Z pence? So here X, Y, Z are just numbers, right? So cost of X pence is Y rupees, right? What is the cost of 1 pen? Let us find, right? Then you can easily find cost of Z pence, right? So we'll consider cost of 1 pen. 1 pen. So if X pence costs X number of pence cost Y rupees. For example, if 10 pence costs 100 rupees, right? So in place of X and Y, if you place 10 and 100, then what's the cost of 1 pen? 1 pen costs 100 by 10, which is 10 rupees, like that. If cost of X pence is Y rupees, what is the cost of 1 pen? So 1 pen costs Y by X rupees, right? Then what is the cost of Z pence? Cost of Z pence. For example, if cost of 1 pen is 10 rupees, what's the cost of 3 pence? 3 pence cost 10 into 3, 30 rupees, right? So here 10 is nothing but Y by Z in this particular case. Therefore, cost of Z pence is equal to Y by X, which is cost of 1 pen, into Z number of pence, right? So here Y by X is cost of 1 pen into Z number of pence. Z number of pence. Therefore, the answer is YZ by X. Cost of Z pence is YZ by X rupees. Option A is the right answer. Question 35. A canteen requires 105 kgs of wheat for a week. How many kgs of wheat will it require for 58 days? For a week means for 7 days. For 7 days, canteen requires 105 kgs of wheat. Therefore, for 58 days, how many kgs of wheat it requires? Very easy answer, students. So, wheat required for 7 days, right? For 7 days, wheat required is equal to 105 kgs. Therefore, for 1 day, or you can directly take for 58 days, right? So, for 1 day, it becomes 105 by 7 days, right? So, for 1 day, it is so 7 into 1, 7 into 5. So, it requires 15 kgs of wheat for 1 day. right? Therefore, so wheat required for 58 days. Therefore, for 58 days, how much wheat is required? 58 into 15 kg, right? So wheat required for 1 day, into wheat required for 58 days, which is equal to, so 15 into 8, 120, 15 into 5, 75, 85, 87, right? So for 58 days, canteen requires 870 kgs of wheat, right? Therefore, option D is the right answer, right? So you can go to step by step like this. Otherwise, directly if you consider the answer, so for 7 days, 105 kgs of wheat are required. Therefore, for 58 days, right? 105 by 7 into 58. Right? This is an easy step. Directly you can get the answer, right? So option D is the right answer. Question 36. The price of 6 toys is 264.37 rupees. What will be the approximate price of 5 toys? As in the previous example, here also, either you can go for direct method, direct trick, that is cost of 6 toys, right? 6 toys costs 264.37 rupees, right? Therefore, 5 toys cost 264.37 into 5 divided by 6. You will get, so you have to find the approximate price of 5 toys. So 264 point, how much? 37 into 5, right? You will get 1321.21.85 divided by 6. You will get 220.308, which is approximately equal to 220 rupees. So cost price of or cost of 5 toys is equal to 220 rupees, right? So this is the direct method, easiest method. Otherwise, you can go step by step, right? So how to find cost of 5 toys? First, let's find cost of 1 toy, right? Cost of 1 toy is equal to cost of 6 toys is 264.37. Therefore, cost of 1 toy is 264.37 divided by 6, right? So you will get 264.37 divided by 6 as 44.06 rupees as cost of 1 toy. Therefore, cost of 5 toys is equal to, so multiplied by 5. You will get again same answer, 220.308. So approximate value is 220 rupees. Right? Therefore, option B is the right answer. Question 37. The cost of 21 pencils and 9 clippers is 819 rupees. The cost price of 7 pencils and 3 clippers is. Here, cost of 21 pencils and 9 clippers is given, right? So, we'll consider one pencil, cost of one pencil as X rupees, one clippers as Y rupees, right? So, let cost of one pencil is equal to X rupees and cost of one clipper is equal to Y rupees. It is given that 21 pencils and 9 clippers cost 819 rupees. Therefore, 21 into X plus 9 into Y gives you 819 rupees. So we need to find cost price of 7 pencils and 3 clippers. That means, so 7x plus 3y is how much? Right? So from the equation 1, if you name it as equation 1, we can take 21x as 819 minus 9y. Right? Therefore, what is the value of x? 819 minus 9y whole divided by 21. Right? So consider this as 2. Right? We are going to find cost price of 7 pencils and 3 clippers. Right? So we'll consider 7x plus 3y. right? So cost of 7 pencils and 3 clippers is equal to, so we'll consider 7 pencils as 7x rupees plus 3 clippers as 3y rupees, right? Substitute the value of x here. X is 819 minus 9y by 21, right? So 7 into 819 minus 9y by 21 plus 3y, right? Now 7 into 3 is 21. So we'll consider 3 as LCM of the two terms here. So denominator becomes 3, numerator becomes 819 minus 9y, right? And the next numerator becomes 3y into 3, right? So which is 9y. So 9y and 9y will get cancelled, minus 9y and plus 9y. So we have 819 by 3. After simplification, yes, 3 into 2, 6, 3 into 7 and 3 into 3, right? So 273 rupees is the cost of 7 pencils and 3 clippers, right? How much? 273 rupees. So option C is the right answer. So this is an easy question, students. First, we have to write the price of clippers and pencils, right? And their numbers, 21x plus 9y as 819 rupees, right? And the question is given as 7x plus 3y is how much? For that, we have to express one unknown term. It may be x or y in terms of another unknown term. You can express y in terms of x or x in terms of y. Here we have expressed x in terms of y, right? We have taken that as equation 2. Substitute equation 2 in equation 1, not particularly equation 1. You can take the value we are going to find, the value of or the cost of 7x plus 3y, right? So substituting the value of x, you will get the answer as 273, right? Which is cost of 7 pencils and 3 clippers. Therefore, option C is the right answer. Students, if you want to practice such questions, please visit our website www.examsnet.com. You can also download our app. The link is given in the description box. Question 38. If X men working X hours a day can do X units of work for X days, then Y men working for Y hours a day would be able to complete how many units of work in Y days? So to answer this question, students, we are using the concept of work. So here work is equal to, it is always efficiency into time. Efficiency into time. Efficiency is nothing but how efficient the persons are, right? So what is the capacity of that person or how many persons are working is called efficiency in this particular case. Therefore, we can consider efficiency as number of persons working in how many days, and also number of hours per day is given in this particular question. Therefore, time will be considered as number of hours in a day into how many days they are working, right? That gives total number of hours they are going to work. Therefore, number of persons into number of days into hours gives the total work, right? So here X men, they are working for X hours in a day, right? Can do X units of work in X days. So we'll consider this right hand side part. Number of persons are X persons, right? Into they are working for X number of days, X days, right? Into every day they work for X hours is equal to product of efficiency into time gives the total work. Here the total work is X units of work, right? X units of work, right? So then Y men, they work for Y hours a day, and they work for Y number of days. Can do how many units of work? They are asking. Before going to Y units of work, so we'll consider one person. If X persons can do X units of work, so what is the unit of work can be done by one person, right? Simultaneously, we'll take one person. One person can do X by X, 1 unit of work, you can say. But along with number of persons, here are number of days and hours also, right? Therefore, we'll consider one person in 1 day, right? And also in 1 hour, what is the amount of work done by one person, right? If he does the work in only in 1 day, and in every day, if he works for only 1 hour, what is the amount of work done by him? So this gives X by these units, X number of persons, X into X number of days into X number of hours. For example, if a person, not particular one person, if 18 persons, if they work for 2 number of days, and every day if they work for 12 hours, right? And some unit of work, so X units of work they are going to do, right? Right? So how one person in 1 day and in 1 hour, what is the amount of work done by one person in 1 day and 1 hour, right? This gives X divided by 18 into 2 into 12. In the same manner, so to the given question also, amount of work done by one person per day and also in 1 hour, right? So which will be equal to X divided by X into X into X. Here, these three X's are number of persons and number of days and number of hours. Therefore, you will get X by X square. Sorry, 1 by X square. 1 by X square is the amount of work, right? X square units of work done by one person in 1 day and in 1 hour, right? Therefore, work done by Y men, Y number of men, right? Therefore, Y men in Y days, Y number of days, and in Y hours is equal to, right? If one person can do 1 by X square units of work, right? So work done by one person into work done by Y persons in Y days in Y hours, right? Into Y. Therefore, one person can do 1 by X square units of work into Y cube. Therefore, Y cube by X square is, so we'll write units. Y cube by X square units is amount of work done by Y men in Y number of days and in Y hours, right? So, option A is the right answer. Question 39. If the cost price of 16 mugs is 116 rupees, how much does a set of 5 dozen mugs cost? Cost price of 16 mugs is 116, right? So 16 mugs cost 116 rupees. Therefore, 5 dozen. 5 dozen means, so 5 into 12 mugs. So 12 into 5 is 60, right? So for 116 by 16 into 60. Right? So 4 into 4, 4 into 15, and 4 into 2, 4 into 9. 29 into 15 is equal to, so 15 into 9, 135. 15 into 30 plus 13, 43. So how much? 5 dozen mugs cost 435 rupees. Option D is the right answer, right? So otherwise, first you can take what is the cost of one mug. Cost of 16 mugs is given, right? So another method is find the cost of one mug. One mug costs 116 rupees by 16, right? So because 16 mugs cost 116 rupees, right? So 4 into 4, 4 into 2, and 4 into 9. So 29 by 4 rupees. Cost of one mug is 29 by 4 rupees. Therefore, cost of 5 dozen mugs. 5 dozen. 5 dozen in the sense 60 mugs, and each mug costs 29 by 4 rupees, right? Cost of 1 mug is 29 by 4 rupees. Therefore, cost of 60 mugs. You will get the same answer. 15 into 29, which is 435 rupees. Therefore, option D is the right answer. Question 40. 12 men and 18 boys working 7.5 hours a day can do a piece of work in 60 days. If a man works equal to 2 boys, then how many boys will be required to help 21 men to do twice the work in 50 days, working 9 hours a day? Right? So students, here also we are using the same concept of work, which is efficiency into time. Efficiency into time. Right? So in this particular case, efficiency is nothing but number of persons working, right? So how many persons are working here, or what is the capacity of number of persons, right? Into here time is in terms of days and hours, right? So in how many days they are working, and in each day how many hours they are working. So days into number of hours gives the total time these many persons are working, right? Therefore, work can be considered as number of persons into number of days into number of hours. Keeping this in our mind, come back to the question. Here in first case, we have to consider the total work first. In first case, we have to consider the total work, right? So this total work has been done by 12 men and 18 boys, right? In how many days? In 60 days, right? And in every day, they work for 7.5 hours. And it is given that one man works equal to 2 boys. So one man's capacity is equal to capacity of 2 boys, right? So keeping this in our mind, we have to consider the total work done in first case. And in the second case, right? So how many boys will be required to help 21 men to do twice the work? In the second case, the work will be twice the initial work, right? Twice the initial work. Initial work. To do this work, how many boys are required along with 21 men? Along with 21 men, right? And they work for 50 days, and in each day they work for 9 hours, right? So keeping this in our mind, we'll go step by step. So first we'll consider one man is equal to 2 boys, right? So let us represent number of men as X, number of boys will represent their number by Y, right? So let one man be X and one boy will represent by Y, right? It is given that one man is equal to 2 boys, which means X is equal to 2Y, right? So now come to the first case. Come to the first case in which 12 men and 18 boys, right? So 12X plus 18Y, right? So number of persons into number of days. They work for 60 days and every day they work for 7.5 hours. So number of persons into number of days into number of hours gives the total work. Let it be W, right? Here the total work is W. Simplify it. Here X is equal to 2Y, right? One man is equal to 2 boys. So here 12 into 2Y plus 18Y into 60 into 7.5 means 15 by 2 hours is equal to W. Still we can simplify. So here 24 plus 18, so 34, 42Y into 450 is equal to W, or 42 into 450. So 42 into 450 is equal to 18,900Y is equal to the initial work, right? Total initial work is 18,900 Y units, right? So in the second case, so in order to work twice the initial work, right? Twice the initial work means 2 times W, right? 2 times W. So what is the formula here? Number of persons. How many persons are working here? 21 men along with some boys, right? So number of persons are 21 men plus some boys, right? They work for 50 days into 50 days, and every day they work for 9 hours, right? So then what is the number of boys required here? For that, we'll consider 2W. What is 2W? 2 times W is already we had calculated 18,900 Y. This work is equal to 21 men. We are representing men with the symbol X plus boys are Y. Y number of boys into 50 into 9, which is equal to 18,900 into 2 will give you 37,800 into Y is equal to, since 21, X is 2Y. Again, you can consider 21 into 2Y plus Y number of boys into 450, which is equal to 42Y plus some boys. You no need to consider this Y as number of separately number of boys. Instead of writing Y, you can directly take number of some boys are required, right? Right? 42Y plus some boys plus, sorry, into 450. Therefore, you will get 42Y, right? Plus, here 42Y is equal to 21 men. Along with 21 men, some boys are required, is equal to 37,800 by 450. So we'll keep Y separately, right? So, sorry, divided by 450. So you will get 84. 84Y, right? This means, so just neglect this Y here, right? So along with the 42 boys, some more boys are required. What is that number? 42 more boys are required, so that the total becomes 84, right? Therefore, so here boys are represented with Y, right? So for number of boys required along with men is equal to 84 minus or 84Y minus 42Y, which is again 42Y, right? 42 boys are required, right? Otherwise, you can take directly 42Y as 21 men plus number of boys required is equal to 84Y. 84Y represents 84 boys, right? Therefore, number of boys required becomes 84Y minus 21 men. 21 men is nothing but 21 into 2 boys, right? 42 boys. 84Y minus 42Y, right? 42 boys. Therefore, you will get the same answer. 42 boys are required, right? Along with how many men? 21 men, right? So that the work gets doubled. If they work for 50 days and 9 hours a day, work gets doubled. It becomes 2W, right? Therefore, option C is the right answer. Here the question is, how many boys will be required to help 21 men? 42 boys will be required to help 21 men, right? So option C is the right answer. With this, I'm completing this paper. If you want to practice all questions from this paper and many more questions from different topics, please visit our website www.examsnet.com. You can also download our app. The link is given in the description box. I wish you all the very best for your future exams.